when encountering a public utility company in direct violation of the National Electrical Code, specifically concerning the absence of oxidant inhibitors on aluminum wiring connected to a meter bank, several recourse options exist for an inspector. Firstly, contacting the authority having jurisdiction, often referred to as the AHJ, is paramount. The local building inspector or electrical inspector possesses the explicit authority to issue citations and rigorously enforce the provisions outlined in the NEC. Secondly, depending on the specific state regulations, reporting the violation to the state electrical board may be an effective avenue. Certain states maintain regulatory boards that exercise oversight over electrical contractors and inspectors. Filing a formal report with this board initiates a comprehensive investigation, potentially leading to disciplinary action against the utility company. Thirdly, if the utility company operates under the regulatory purview of a state or federal commission, formally filing a complaint becomes crucial. The complaint should meticulously detail the specific NEC violation observed. The Commission is then empowered to conduct a thorough investigation and, if warranted, implement appropriate enforcement actions. Fourthly, meticulous documentation of the evidence is essential throughout this process. Taking clear photographs or videos illustrating the improper wiring practices provides irrefutable visual evidence of the violation. Furthermore, obtaining written statements from fellow inspectors or qualified electricians who have independently witnessed the non-compliance strengthens the case. Maintaining a comprehensive record of all correspondence, interactions, and communications with the utility company creates a well-documented timeline of events. Addressing the inevitable uproar that may arise from refusing to approve meter installations requires a strategic approach. Educating the utility company about the inherent safety hazards associated with neglecting oxidant inhibitors on aluminum wiring is paramount. Explaining the specific NEC requirements pertaining to this practice clarifies the legal and safety implications of their actions. Providing the utility company with copies of the relevant NEC articles and any supplementary documentation that substantiates your position reinforces the validity of your concerns. Maintaining a calm and objective demeanor in all interactions with the utility company is crucial. Avoiding confrontational language or accusatory statements promotes a more productive dialogue. Seeking support from fellow inspectors, contractors, or industry organizations who can articulate the critical importance of adhering to electrical code strengthens your position. Staying persistent in your efforts to enforce NEC requirements is paramount. Consistently following up with the utility company, the OJ, and other regulatory bodies until the issue reaches a satisfactory resolution demonstrates your commitment to safety and code compliance. It is essential to acknowledge that the utility company may have its own underlying reasons for deviating from the standard practice of using oxidant inhibitors, such as cost considerations or logistical challenges. Exploring potential alternatives or compromises that still fulfill the intent of the NEC while addressing the utility company's specific concerns may lead to a mutually acceptable solution. Continuously assessing the potential impact of the NEC violation on public safety and property should remain a central focus throughout the resolution process. Aluminum wiring, when not properly installed and maintained, presents specific hazards. One primary concern is its tendency to expand and contract more than copper wiring with temperature changes. This expansion and contraction can loosen connections over time, leading to increased resistance at the connection points. Increased resistance generates heat, which can, in turn, lead to oxidation and corrosion of the aluminum, further exacerbating the problem. Overheated connections are a significant fire hazard, potentially igniting nearby insulation or other combustible materials. Oxidant inhibitors, also known as antioxidant compounds, play a vital role in preventing corrosion in aluminum wiring connections. These compounds are specifically formulated to create an airtight seal that prevents oxygen and moisture from coming into contact with the aluminum. This protection is crucial because aluminum, when exposed to air, forms a layer of aluminum oxide, which is non-conductive. While this layer protects the underlying aluminum from further corrosion, it also increases the resistance at the connection point. Oxidant inhibitors disrupt this process by penetrating the oxide layer and establishing a conductive path between the aluminum conductors and the connector. This ensures a stable and reliable electrical connection. The NEC mandates the use of approved connectors and termination techniques for aluminum wiring to mitigate the risks associated with its use. Section 110.14b of the NEC addresses the compatibility of conductors and equipment, requiring that they be suitable for the conditions of use. This includes proper termination methods and the use of appropriate connectors designed for aluminum wiring. Furthermore, Section 310.15 outlines the ampacity requirements for conductors, which may differ for aluminum compared to copper due to its high resistance. When inspecting a meter bank, it is essential to look for several key indicators of proper aluminum wiring installation. Firstly, all connections should be clean and free of corrosion. Any signs of oxidation, such as white or grey powdery deposits, indicate a potential problem. Secondly, connectors should be specifically listed and labeled for use with aluminum conductors. These connectors are typically made of aluminum alloy and are designed to maintain a secure and reliable connection. Thirdly, oxidant inhibitor should be visible at all termination points. It should be applied liberally to ensure complete coverage of the conductor and connector. Fourthly, conductors should be properly sized according to the ampacity requirements of the circuit. Undersized conductors can overheat, leading to premature failure and fire hazards. Fifthly, all connections should be torqued to the manufacturer's specifications. Over or under tightening can damage the connector or conductor, compromising the connection. If any of these indicators are absent or deficient, it is crucial to address the issue immediately to prevent potential safety hazards. In addition to visual inspection, other methods can be used to assess the integrity of aluminum wiring connections. Thermal imaging can detect hotspots caused by loose or corroded connections. A thermal imager measures the infrared radiation emitted by an object, displaying it as a thermal image. Overheated connections will appear as bright spots on the image, indicating a potential problem. Voltage drop testing can also be used to identify high-resistance connections. This involves measuring the voltage drop across a connection while the circuit is under a load. A significant voltage drop indicates a high-resistance connection, which may be due to corrosion or looseness. Microohmmeters can accurately measure very low resistances, allowing for precise assessment of connection quality. These instruments are particularly useful for identifying subtle increases in resistance that may not be detectable with other methods. Staying updated on the latest NEC requirements and industry best practices for aluminum wiring is crucial for ensuring electrical safety. The NEC is updated every 3 years, incorporating new technologies and addressing emerging safety concerns. Participating in continuing education courses and attending industry conferences can help inspectors and electricians stay informed about the latest developments in electrical codes and standards. Consulting with experienced electrical engineers or certified master electricians can provide valuable insights into complex wiring situations and help ensure compliance with all applicable codes and regulations. Remember that the ultimate goal is to protect public safety and property by enforcing the highest standards of electrical safety. By diligently inspecting aluminum wiring installations and taking appropriate action when violations are found, inspectors play a vital role in preventing electrical fires and ensuring the reliable operation of electrical systems. The importance of proper grounding and bonding in electrical systems cannot be overstated, especially when dealing with aluminum wiring. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices, such as circuit breakers and fuses, to quickly trip and interrupt the flow of electricity during a fault condition. Bonding ensures that all metallic parts of the electrical system are electrically connected, minimizing voltage differences and reducing the risk of electric shock. Aluminum wiring requires special attention to grounding and bonding due to its susceptibility to corrosion. Corroded connections can increase resistance, compromising the effectiveness of the grounding and bonding system. Therefore, it is crucial to use approved connectors and termination methods that are specifically designed for aluminum wiring. These connectors typically feature corrosion-resistant materials and provide a secure, gas-tight connection that prevents moisture and oxygen from entering. The NEC provides detailed requirements for grounding and bonding in Article 250. This article outlines the specific methods and materials that must be used to ensure a safe and effective grounding and bonding system. It also addresses the grounding of equipment and enclosures, as well as the bonding of metallic piping systems and other conductive elements. When inspecting an electrical system with aluminum wiring, it is essential to verify that the grounding and bonding system is properly installed and maintained. This includes checking the size and condition of grounding conductors, ensuring that all connections are tight and free of corrosion, and verifying that all metallic parts are properly bonded together. Any deficiencies in the grounding and bonding system should be corrected immediately to prevent potential electrical hazards. Surge protection is another important consideration for electrical systems with aluminum wiring. Surges, or transient overvoltages, can damage electronic equipment and electrical components, including aluminum wiring connections. These surges can be caused by lightning strikes, utility switching, or other electrical disturbances. Surge protective devices, or SPDs, are designed to protect electrical systems from these harmful surges. SPD divert the surge current to ground, preventing it from reaching sensitive equipment. The NEC requires the use of SPD in certain applications, such as dwelling units and critical systems. When selecting an SPD for an electrical system with aluminum wiring, it is important to choose a device that is specifically rated for use with aluminum conductors. These SPD typically feature terminals made of corrosion-resistant materials and are designed to provide a secure and reliable connection to aluminum wiring. Regular maintenance and inspection of aluminum wiring connections are essential for ensuring long-term reliability and safety. Over time, connections can loosen due to thermal cycling, vibration, or corrosion. These connections increase resistance, which can lead to overheating and potential fire hazards. Therefore, it is important to periodically inspect all aluminum wiring connections and tighten them as needed. During these inspections, it is also important to check for signs of corrosion, such as white or grey powdery deposits. If corrosion is present, the connection should be cleaned and re-terminated using approved connectors and oxidant inhibitor. Infrared thermography can be a valuable tool for identifying overheating connections in aluminum wiring systems. By scanning the electrical system with an infrared camera, it is possible to detect hotspots that indicate loose or corroded connections. These hotspots can be easily identified on the thermal image, allowing for targeted maintenance and repair. Another aspect of aluminum wiring that warrants attention is its compatibility with various types of insulation. Some types of insulation can react with aluminum, leading to corrosion and degradation of the wire. Therefore, it is important to use insulation that is specifically approved for use with aluminum conductors. The NEC specifies the types of insulation that are suitable for use with aluminum wiring in Table 310.104a. This table lists the allowable insulation types based on their temperature rating and other characteristics. When installing or repairing aluminum wiring, it is essential to use the correct type of insulation to prevent potential problems. Labeling and documentation are also important considerations for aluminum wiring systems. All aluminum wiring connections should be clearly labeled to indicate the type of conductor and the need for special handling. This labeling helps to prevent confusion and ensures that future maintenance and repair work is performed correctly. It is also important to maintain accurate documentation of all aluminum wiring installations, including the type and size of conductors, the type of connectors used, and the date of installation. This documentation can be valuable for troubleshooting and future reference. Educating homeowners and building occupants about the proper care and maintenance of aluminum wiring is also crucial for preventing electrical hazards. Homeowners should be advised to contact a qualified electrician if they notice any signs of problems with their electrical system, such as flickering lights, warm outlets, or burning smells. They should also be instructed not to attempt to repair or modify aluminum wiring connections themselves, as this can be dangerous. Utility companies also have a responsibility to ensure the safe and reliable operation of their electrical systems, including those with aluminum wiring. This includes implementing regular inspection and maintenance programs, providing training to their employees on the proper handling of aluminum wiring, and responding promptly to reports of electrical problems. By working together, inspectors, electricians, utility companies, and homeowners can ensure the safe and reliable operation of electrical systems with aluminum wiring. The NEC serves as a foundation for electrical safety, and strict adherence to its requirements is essential for preventing electrical fires and protecting lives and property. Continuously seeking knowledge and staying informed about the latest advancements in electrical technology and safety practices will contribute to a safer electrical environment for all. In the context of meter banks, the proper installation and maintenance of aluminum wiring are particularly critical due to the high concentration of electrical connections in a confined space. Meter banks typically serve multiple dwelling units or commercial establishments, making the consequences of an electrical fire potentially catastrophic. Therefore, meticulous attention to detail and adherence to all applicable codes and standards are paramount. When inspecting a meter bank, it is important to pay close attention to the grounding and bonding system. The meter bank enclosure should be properly grounded to a grounding electrode system, such as a ground rod or a metallic water pipe. All metallic components of the meter bank, including the meter sockets, enclosures, and conduit, should be bonded together to create a low impedance path for fault current. The grounding and bonding conductors should be sized according to the requirements of the NEC and should be securely connected to the appropriate terminals. The meter sockets themselves should be specifically listed for use with aluminum conductors. These sockets typically feature pressure connectors that are designed to provide a secure and reliable connection to aluminum wiring. The connectors should be properly tightened to the manufacturer's specifications to ensure a good electrical connection. Oxidant inhibitors should be applied liberally to all aluminum wiring connections within the meter bank. This helps to prevent corrosion and maintain a low resistance connection. The conductor should be properly supported and protected from physical damage. The meter bank enclosure should be adequately ventilated to prevent overheating. Overheating can accelerate corrosion and degrade the insulation on the conductors. The meter bank should be readily accessible for inspection and maintenance. The area around the meter bank should be kept clear of obstructions to allow for easy access. Regular inspections of the meter bank should be conducted to identify any potential problems. These inspections should include a visual examination of the wiring, connectors, and grounding system, as well as thermal scanning to detect overheating connections. Any deficiencies should be corrected promptly to prevent potential electrical hazards. Cooperation between the utility company, the electrical contractor, and the building owner is essential for ensuring the safe and reliable operation of the meter bank. The utility company is responsible for providing a safe and reliable electrical supply to the meter bank. The electrical contractor is responsible for installing and maintaining the meter bank in accordance with all applicable codes and standards. The building owner is responsible for ensuring that the meter bank is properly maintained and that any problems are reported promptly. By working together, these parties can help to prevent electrical fires and ensure the safety of the building occupants. In addition to the technical aspects of aluminum wiring installation and maintenance, it is also important to consider the legal and regulatory requirements. As an inspector, you have a responsibility to enforce the NEC and other applicable codes and standards. If you encounter a violation, you have a duty to take action to correct it. This may involve issuing a notice of violation, requiring the utility company to make repairs, or even shutting down the power to the meter bank. It is important to document all violations and actions taken to correct them. This documentation can be valuable in the event of a legal dispute or an insurance claim. You should also be familiar with the procedures for appealing a decision of the AHJ. If you disagree with the AHJ interpretation of the code, you have the right to appeal the decision to a higher authority. It is important to remember that your primary responsibility is to protect public safety. You should not be intimidated by the utility company or any other party. You should always act in accordance with your best judgment and in the interest of public safety. Enforcing electrical codes can sometimes be challenging, especially when dealing with powerful organizations like utility companies. However, by being knowledgeable, persistent, and professional, you can make a difference in ensuring electrical safety and protecting lives and property. Continuous learning and professional development are essential for staying up to date on the latest codes, standards, and technologies related to aluminum wiring and electrical safety. Attending industry conferences, taking continuing education courses, and reading trade publications can help you expand your knowledge and skills. Networking with other inspectors and electrical professionals can also provide valuable insights and support. By investing in your professional development, you can become a more effective and confident inspector.